Okay, so let's go through and look at necessarily the slide method with the problems that you sent me, or at least starting to send me. So looking at this one's number 9 on 2-3. First off, when you go through and look at it, you should see that you have a 2, an 8, and a 42. So you can pull out a greatest common factor of 2, most definitely. And then you have 6 x's in the first term, 5 x's in the second term, and 4 x's in the last term. So you can pull out an x to the 4th out of each. So if we divide out a 2x to the 4th out of each part, looks like we're left with x squared minus 4x and minus 24. Okay, and then in this particular one, this 2x to the 4th is going to stay. However, this part we can go through and factor. And this one doesn't have a number in front of x squared, so you really don't have to use any sort of method. You just have to find, I'm going to change color here. You just want to find two numbers that are going to multiply to this number, but add to this number. Okay. So in this case, we want to find two numbers. Oops, it is going to be x and x because it's an x squared. So two numbers that are going to multiply to negative 24, but add to negative 4. So let's see. I'm trying to think just off the top of my head. Numbers that multiply to 24 would be like, you know, I know it has to be negative, but numbers necessarily would be like 2 and 12, 3 and 8. You could have 4 and 6. And I think that's all of them. Let's see. Oh, hold on. This would make it a little bit clearer. Half of 42 is actually 21. That makes a little bit better sense. Sorry. It's been a long night. Okay, so two numbers that are going to multiply to negative 21 but add to negative 4. So that makes that a little bit easier. That would be negative 7 and positive 3. Because negative 7 times 3 is a negative 21, but if you add those two together, you get that negative 4. So this right here would be your most complete factored form, if that's all you're doing is going through and just solving, or factoring at least. Alright, so I'm going to move on to the next one that you sent me. Okay, when you see one like this, automatically it has 4 terms. So when you have 4 terms, it's probably a factor by grouping. And for a factor by grouping, you want to go through and split it in half. So I'm going to put a red line in there and kind of split it in half. And you pull out a greatest common factor out of this first term, or this first part right here. Well, I see I have a 5 in common, so I can pull out a 5. And I have 3 z's and 2 z's, so I can pull out a z squared. Well, what I would have left if I divide out a 5z squared out of each of those, I'm left with a z, sorry, that's my goofy z's, z plus 1. And the nice thing with factor by grouping is this factor right here is going to be the same factor for right here. You just have to figure out what number goes in the front. And the only number that can go here and multiply out to this at the top is going to have to be a negative 6, because negative 6 times z is negative 6z, negative 6 times 1 is negative 6. Now, these are really easy to write your factored form if you're doing factor by grouping. This one and this one right here, those two go together to be one of your factors. And the one in the parentheses that they have in common is your other factor. So that's a factor by grouping. That was number 10 on that one. Okay, moving on to number 11. Alright, so on number 11, this is going to be more of your traditional slide method to it. So what you want to do with your slide method is you want to go through and take, if there's a number in front of x squared, you want to go through and multiply it to your last term. So if we do that, we're left with x squared minus 22x. Alright, and then 12 times negative 20 gives us negative 240. Alright, so now comes the fun part. We've got to find two numbers that are going to, sorry, I'm changing colors, multiply to this one, but they have to add to this one. And this is kind of where it's going to take a little bit of time and kind of trial and error, especially in your calculator. Well, since it's x squared, it's going to be x and x. So now we got to spend a little bit of time and try to find two numbers that are going to multiply to negative 240, but they're going to have to add to negative 22. Alright, and it took me a second to find, but two numbers that are going to multiply to negative 240, but add to negative 22 would be negative 30 and positive 8. Because negative 30 times 8 is negative 240, but if you add them together, you get negative 22. Now, the part that people forget when you're doing that slide method is if you had to divide away or multiply away a number initially, you have to divide that number back in. And that's the part that people tend to forget. So now on this one, when I divide it in, it doesn't divide evenly, which is okay. But you want to go through and simplify if you can. So let's see, 30 over 12. It's been a long night, not thinking too hard. It's going to reduce to 5 over 2. And then 8 over 12, we can divide each of them by 4. And we should get through 2 over 3. Okay. Oops, my pen's not working very well, sorry. 2/3. Okay. So, in this case, you can't leave it like this if you're trying to factor. What you end up doing is this number that's at the bottom is going to go in front of the x, so it becomes 2x, and then you keep the minus 5. You do the same thing with the other one. This will become a 3x plus 2. And then there should be our factors that multiply out, giving us this one. This one we could have also pulled out a greatest common factor as well. That would have made it much smaller as well to it. Okay, moving on. Okay, so this one, you can see that this one's smaller. It's just a greatest common factor. So we could pull out a greatest common factor in this case. So we can definitely pull out a 3. And then since we have an m squared, we can pull out an m squared. That's the smallest one that I see. So that's going to leave me with 1 minus 16 m to the 4th. And hopefully you're realizing in the second factor that this one is one of those perfect squares. It'll factor down nicely. So you want to find the two identical things that multiply to this, which is 1 and 1. One's going to be plus, one's going to be minus. And then you need the two identical things that multiply to this, which should be 4m squared. Okay, and that would be our most reduced factored form. Alright, so I'm going to try 13 as well. Alright, so on 13 you had 4x to the 3rd minus 4x squared plus x. Okay, so you want to go through and pull out your greatest common factor, especially anything that you see that has a extra x especially, so I can definitely pull out an x out of each. So that's going to leave me with 4x squared minus 4x plus 1. And then we can go through and do our slide with this portion right here. So, since I do have a number in front of x, I want to take that number and multiply it to the last term. So, what I'm left with is x, and then I'm left with x squared minus 4x plus 4. And now I want to find two numbers that are going to multiply to 4, but add to negative 4, which hopefully you recognize is pretty easy, which is x minus 2 and x minus 2. Because negative 2 times negative 2 will give you a positive 4, but if you add them, you get the negative 4. So there's our factored form down. Again, though, when you do the slide method, if you multiply away a number, you do have to divide that number back in. So, this one, again, 2 over 4 reduces to 1/2, so technically it's 1/2, 1/2. So I can pull a 2 in front of the x, minus 1, and another factor of 2x minus 1. And that's our most reduced factored form. Let me go back and look at 11 again. I think, let me see, again, I'm just quickly going through and factoring these. The only thing that's bugging me is the fact that you have this and this, which 2x and 3x will multiply to 6x and not 12x. So it looks like I'm missing, since I get to 6x, it looks like I'm missing a 2 on the outside. Not that it really affects it too much when you're factoring, but yeah, sorry, that just jumped into my mind. Because now it would multiply out like it's supposed to. Sorry about that. Okay. Alright, so I'll do 14 with you as well. That one was 5m to the 4th minus 70m to the 3rd. Sorry, sloppy writing. Plus 245m squared. Okay, so we definitely want to pull out some greatest common factors because this is immensely large. So I can see each number is divisible by 5, so we can pull out a 5. And the lowest variable I see is m squared, so I can pull out an m squared. So that's going to leave me with an m squared. 70 divided by 5, so that would be a negative 14m. And then 245 divided by 5 gives me 49. Okay, and with my slide, I don't really have to multiply out a number because there's no number in front of my m squared. I just got to find the two numbers that are going to multiply to this one. Sorry, sloppy writing, but add to this one when I go through and write my factors. So I get 5m squared. Okay, and because it's just m squared, it's m and m. I gotta find two numbers that are going to multiply to positive 49 but add to negative 14, so hopefully you see those as negative 7 and negative 7, which should be your true factored form to it. Hopefully that goes through and helps you a bit, at least with those. I don't think I already have a video online with the slide method as far as I'm aware, but if you need more help, just let me know.